To verify this identity, I'm looking at the left-hand side and the right-hand side. The left-hand side looks a little more complicated, so I'm going to try to manipulate the left-hand side and make it look like the right-hand side. So starting with the left-hand side, I'm going to make my pen a little smaller here. I get, the first thing I really want to do is get inside those parentheses so I can do something. So I'm going to expand that binomial. So that's 1 plus tan theta squared. So that's a perfect square trinomial. So that's first term squared, last term squared at the end, and then the middle term is going to be 2 times the first and last term. So there's my expanded binomial, foiling that out, and then secant theta in the denominator still. Keeping track of what I did here, so I expanded the binomial by multiplying. All right, my next step then is looking on the here. I need to get a secant and a sine on the left, on the right. There is a relationship between tan and secant. If I take this 1 and the tan squared and put those together. So I'm going to do a little rearranging here. I'm going to put, I'll do it in blue, the 1 and the tan squared together, and that leaves me the 2 tan. So all I did there was change the order. So I'm just reordering. Because addition is commutative, so I can switch the order. So I use the commutative property to change order. So I'm grouping those two together. And I can do that with the addition, and I can add those parentheses. It doesn't change my value because it's just addition. Okay, now I can replace 1 plus tan squared with secant squared using the Pythagorean identity for tan. And then I still have that 2 tan theta and the secant theta. Okay, so now I'm going to decompose these fractions. I'm going to start over here to give myself a little space. I'm going to decompose these fractions, or this fraction to get 2 fractions, kind of unadding, the opposite of adding, undoing what I would have done when I added these 2 together. And now I can reduce the secant, one of those cancels, and I'm left with just one secant on the first fraction. And on the second fraction, well, let's see, I want to end with something in sine, right? I already have my secant down there. I need something with sine. So I'm going to turn tangent and secant and express those in terms of sine and cosine and see if I can get sine out. So I'm going to change that tangent to sine theta over cosine theta. And I'm going to first note that secant is actually in the denominator, so it's actually like 1 over secant theta. And that is cosine theta. And I can, or over 1, I can put that over 1 if I want. So that way it looks like my cosines will cancel and I'm left with just sine, which gives me what I have on the right-hand side, secant theta plus 2 sine theta. And that equals what I have there on the right side, and that verifies that identity.